Hay tanto también atrás, pero no hacen espacio en el micrófono. Antes te más despacio.
Ok.
Ya todo en inglés. It's a cell phone.
Listo.
Beleza. Ya aprendí que con eso no te puedes meter al Hangout. No puedo empezar el Hangout hasta el día de la presentación. Si lo haces antes, para hacer testing de si funciona o no, se daña.
Hey, la presentación en inglés, en español. Whatever.
Idealmente en español, en inglés.
Pero ya dice.
¿No hay gente hablando inglés ahora mismo? O sea, porque eso lo ponemos todos en la página y a Peter le gusta verlas, entonces. Si puedes en inglés, ábrete el link. Lo voy a abrir aquí. Puedes empezar cuando quieras.
Okay, good afternoon, guys. Today we are going to be talking about object tracking using the main library that is OpenCV and a little bit of Python. Like a little Python. But we are going to see that it's not the only language that OpenCV supports. Okay, so what is the goal for this presentation? First off, basic introduction to the OpenCV. We are not going to talk extensively about algorithms, training, or artificial intelligence, so don't expect that. We are going to talk about just how OpenCV works and how can we handle how OpenCV works mostly in the process to manipulate images. So the example that I'm going to show you is going to detect the presence of this ball. Actually, it's so. Okay, initially it was.
Yeah, you got it. It's the TV. Sergio was right. There you go.
So initially, my algorithm was developed using a tennis ball. We don't have that in the office, so I modify a little bit to work with this ping pong ball. So the idea is first how we handle them. We're going to handle the images and the rotation of the ball, and after that, how we are going to track it. Okay. This is like I told you, this is a very basic algorithm that I found on the internet that it suits my need for what I wanted to learn. So, first of all, what is OpenCV? For those that doesn't know, it's an open source computer vision library. Open source computer vision library. And it also handles machine learning, so you can train. There are some algorithms for OpenCV that you can train and learn, so they can learn what you are trying to achieve. So it's not just a image manipulation. It provides a common infrastructure for everything related with vision, with images, in computers. It supports Java, C, C++, and also Python. The Python developer, the examples that we are going to see they are going to be in Python. The current version is version 3. Exactly, is version 3.4.2, if I'm not mistaken. And there are some compatibility issues with the version 2, so this code doesn't work not that much with version 2. So we want to learn version 2, it's going to change a little bit. But the logic is almost the same. The way that the library works is almost the same. Okay, what are the advantages of OpenCV, or why we decided to OpenCV? It's the most common used library for manipulation, for visual manipulation. It's very efficient, and also is really good at processing real-time images. So I have seen like 2 or 3 other libraries, but because this one is open source and is the one that you can find most of the good tutorials, I decided to give it a try with OpenCV. So, what is object tracking? Well, it's locating an object inside one still image, and then detecting how this image moves inside this, how this object moves inside this image. Remember that all video is a continuous sequence of frames. So actually, what we are going to do is capture each one of these frames, analyze it, and then do the tracking. So that is object tracking goes, and that guy has solved everything. Okay, it's different. Object tracking is different of face detection or object detection. It is the algorithms for object tracking are more optimized and faster. So that's why it's a very good alternative when object detection doesn't work. Normally, the algorithms for detections are more complex and are slower, so you got the brain and you can work out with the object tracking.
Why is it failover for detection?
Because when you are, for example, for face detection, there are several algorithms that you can teach them how to track the face, but there are some times that this algorithm fails. So as a failover, you can switch to object tracking of the previous frame in that object. So instead of tracing or trying to detect the image in the next frame, you can just follow the tracking. Yeah. It's a little bit complex, but to achieve that, but it's highly recommended. And there are several other algorithms for face detection and tracking. Okay. So the first example that we are going to look is how we can load an image to OpenCV using Python. Let's see the first one. Okay, as you see, the code is pretty simple. We just import the CD2 library. We assign, there is a property function that already loads the image, and we can assign that in a variable, and then display the image. Then we have to wait for any key, and we close the window. So we are running that. So that's it. We get the first image on a window using the library.
Presentation. Yes, again, like, that what is our
No, que va a tener no.
So that's it. We have a rematch and we load it inside a window. One of the things that OpenCV does is we can manipulate the images. So also instead of just loading an image, we can add text to an image. Just going to let's see how can we add text. So if you look at this, it's almost the same. Importing the library, loading the image. There are several predefined fonts already in the library. This is the one that we are using. It's Archie. It's just some constants that are defined inside the library. And then there is a function to put text, so you can specify the coordinates where you want that text to appear. Everything is just after that we just show the image. So you can see the image with the text that we already put in. So after that, we can also draw different objects. One of those objects is the circle. This is actually more or less, that's why I call that file create mean, because this is more or less how the mean generators that we see on internet work. You can define some areas and just put the text. Or they're more sophisticated because they change the font size and everything. So next one, we're going to insert a circle. I think all of us have experience working with paint or some image manipulation software. Where it's the same, we can draw a circle. There is already a function in there that is called a circle. We specify in what image we want that circle, in what position. That's it. The simple just what image we want that circle. Starting a couple of lines. And there we have it. So this is the foundation, so we can start tracing our objects, at least for manipulating the images. Remember, we are going to work all these frames. So what is the next step? Okay, if we want to detect an object first, the main problem is that in real life, we don't have pixels that normally represent a specific object. The amount of pixels in an image is not the same for an object in real life. So what does this mean? Well, the clustering of color pixels doesn't mean that they belong to the same object. Probably we have two bosses that are from the same color of yellow, one next to the other, so we cannot determine, or we have to process it a little bit more on how to determine those, and probably there is some human interaction in there, so we can identify each object.
Sorry, I'm going to interrupt you once more. Just trying to present the proper. Right.
Okay, what does we mean about this? Well, we have this example picture. There is a fish in there, so for a software algorithm, it's going to be pretty hard to determine where is the fish around, where is the sealant. So even for us, it's a little bit hard. So imagine if we have to develop an algorithm so we can determine where the fish is. It's pretty hard. Okay, what is the proposed solution for this type of issues? This called segmentation. Well, there are several kind of segmentation that we can do. We can use algorithms for edge detection. We can have algorithms that can eliminate some background and then specify certain areas that are taken for the object that we are looking for. But there are like I think like 3 or 5, like 4 or 5 algorithms that we can work out. But the one that I decided, because the objective when I started looking for a solution for the idea that I have is to trace some certain objects that they already have a specified color. It's more easier because we can have the idea was not to have an application that can work in an uncontrolled area. So you can have control of the area. So the idea that I had was to track a tennis ball, for example, or an object that has a certain color. So for this, the easy solution, or the one that worked out more for me, is using what is called the blur and threshold. That we can modify the image for that frame and identify which area is from the color that I am looking for. In this example, the main color is yellow green. So how we achieve that on Python with OpenCV? Okay. Same as the previous example, in this example I'm loading the image that we have in the presentation. I'm showing it, and in this example, I'm showing the different states or different modifications that I made to the image, so I can detect where the ball is, where the tennis ball is. So for this, I defined 2 HSV colors. That is the minimum gradient for that color and the maximum gradient. There is already in place another program that can help you to do that. In this case, I selected a very wide range of yellowish green. So I defined those, and then I resize line 16. I resize the image because in smaller images we can process it more faster. So I resized it to 600 pixels. Then, remember that the technique is called blur and threshold. Well, the main algorithm that all image manipulation software use for blurring is the Gaussian algorithm. So OpenCV already have a function for that. We can grab that image and blur it. That way we can remove all the edges in certain images and have a very smooth color all around. So after that, we grab that modified image with CDD color, and what this does is to turn it into a black and white picture, but very extreme, no gray areas, just black and white. The part that was blurred, it was going to be that matched the color is going to be the one that we are supposing that is going to be the ball. So that is achieved with the in-range method. There's these other two algorithms that also do help us improve and remove the smallest patches that we have for that blur and that HSV color, and then we display. So we have the image, we have the volume there. This is the first flow. With the first transformation, you get to get this kind of blurry and change image. So if you notice, it's going to be easier for us to detect where the ball is in this algorithm.
What is that white portion below the ball? Is that the shadow or is it something else?
I think it's the line.
The line.
Yeah.
The high contrast area in the line.
Yeah. Yeah. Remember, it's not perfect because we have to define a very wide range of
color
that is going to match the object that we are trying to track.
Usa como algo que te parece.
Okay, so that's the first step. The next step is because I already know that it's going to be a ball, so I have to, what is the object that I want to trace? What is the figure that I expected to trace? It's a circle. So it's more easier for me to, if we have different matches for that, for the previous image with the blur and the HSV modifications, the threshold modification, we can have different objects that have that match, but probably they're not going to have the same figure. Probably they're going to be rectangles, squares, or something like that. So what I'm trying to do is to search in all the modified image, where is the circle where is the white part that most match the circle? For that, also OpenCV also have a method, so it's pretty easy for us. It's the same file. Just wait for the press. Make sure this is not right. Okay, define the image, load the image, define the colors that I'm going to work with, apply the blur, display it. Okay, and this is the one that changed. Like I told you, OpenCV already have that that function that makes us find different contours or different objects that match certain patterns. The next line, if you see, I assign very elegant, but I assign the first element of the array to the same variable. But this is because the algorithm was for OpenCV2, and I have to modify it for OpenCV3. And then it's the fastest way to do it was doing that very ugly patch there. And I define that there is no center. Because it is a circle, what I am looking for, I have to define a center, a point in the image that is going to expand and see if that matches a circle or not. So the first one, I don't know where it is. And for all the matches or all the contours that were fine, to check if we already have contours on the images, we're going to have more than one or at least one. So we calculate, for the first one, we calculate where is the center. And for that, we use the max function, that is just works with a difference, so we can determine the center. And this is the function that I told you that they already have. We already have the center that we are going to look at, and we are going to extract everything around it. The center and the radius of that match. So we're going to see how this works. Okay, same. We have the same image. We apply the sorry. We apply the probe. If you notice, you already determined the center of the object. And also, there is a little bit over there where the circle matches that center. So we are going to grab all that area, and we are going to say, oh, this is a circle, so this must be the ball. Or in the next image, we end up with this. And that's how we detect the object. In this case, like I told you, it's more simpler because you already know the.
It's weird, the line you said.
Yeah, because
Where did it take you?
So, how everything works together? Well, we just make a cycle, a loop, and then wait for a key to be pressed to break. Yeah. So we are going to test it. Sorry, this one, sorry, that's my mistake. Remember that we were working only with one image, right? So we have to find a way to work with the video. So for this, we use an external library that is IAMutils that already have this library already have everything in place for image for device capture. In this case, I'm going to use the video stream. That what it does is detect my webcam and then assign it to a file that is going to be capturing all the frames one by one, and if you want to be stored there. This time sleep is because normally the webcams it's a start of time then going. So this is just for making the camera work. So there we have. This is on my webcam, and that's it. It's just like 30 lines of code. That's it, just to capture. And if you see here inside the loop, we keep reading every frame and assign it to that frame. So that's the object that we are going to be analyzing every step in the loop. So inside of this code, we just have to put all the code that we already show, and it's going to be tracing the code. So this one. So this one is the one that is traced the balls. Same camera. The camera wasn't detected. Closer. So I just start detecting the ball.
Oh, nice.
This is the simplest tracking algorithm that you can work with. There's, like I'm going to show you.
Yeah. Do you check it or the thing?
There's a ball in the one. So, there's my presentation. Already see me capture the video. See me put everything together. Size, remember the steps, capture the video. In this case, the frame for the video. Resize it. If you remember the first time that we saw the camera, it wasn't a big screen, so we resized it to 600. So it is going to be the improved algorithm. For each frame, we apply the same blur, the same threshold, and the same calculation for the center and the circle, the contour, and this is going to be inside the loop until we press a. But wait, there's more. Okay, like I told you, there are several algorithms that OpenCV already have in place, so we don't have to do everything that we did in this example.
That's what I was wondering.
Yeah, they are very, very good. The first one, the boosting, is the one that nobody recommends. It's 10 years old and nobody works with that. The three next, MIL, KCF, and TLD, are the more
modern
performance. They have better performance. Medium flow is very good at detecting, but it's a little bit slower and it fails a lot. You train him, and you can train him a lot, but it's not that safe to be following or detecting the things that we want. And the low turn and Mosel, sincerely, I haven't touched them. And the last one is it was incorporated in OpenCV 3.4, so it's a new one also. And I have a small example, but for these algorithms work the following, dividing the problem into separate solutions. First, they call something they have something that is called the motion model. That what it does is detect the speed and the direction of the object that we want to identify or track. And with this, it compares that area with the in the next frame. It compares that area with the previous one. So this way, you can determine the speed and the change in the model. And the other thing is the appearance of the model. Remember, in this example, because it's very, very easy, our model is a circle and it's not going to change. But in real life, one car can be seen from the front and then change to the side. So that we have to train the algorithm to detect those changes. And that is the appearance model. We can train the algorithm to detect those changes in the object that we are trying to track and identify. So, remember the guy in the first screen, the face detection. This is an example, more or less. In this example, I already have an array that we can select which algorithm we want to use for the detection. This is a more simple example because we define what object. We can select the object that we want to trace, and the algorithm, because we're going to see it, we can draw a rectangle in the object, and then we can follow up. The algorithm is in charge of following up, so it's going to be a lot easier. Try this square. So this algorithm has how it works. We have the first image to verify next picture. But here we can determine what object we want to trace. So
any keywords?
yeah, just keep pressing it. No, keep it pressed. Oh, that's good.
Just keep it going.
You see?
Let's play ping pong and see if it tracks the ball.
Good idea.
So we have the first frame. Say, I want to trace this object. Press enter. It's not working. It's very application. I don't know, it's duplicated the application. I have another one here. Well, sorry about that. But the idea is that you can define what object you can trace and keep tracking out. And then it's going to be the normal guy with the scroll things. So you can move the object there. So,
But that kind of training works for objects that don't change.
yeah, actually, there are already algorithms that already have the training. For example, the one that that Facebook use is called Viola. Something I don't remember the other guy. That they already train the algorithm and improve the algorithm so they can detect and determine where are the images, where are the faces. That algorithm is exclusive for faces.
For face.
Yeah, there is another algorithm that is exclusive for peasants. That you can have a security camera and they can determine where a person is walking. So I also have some reference there. You want to learn more about OpenCV? So, thank you.
So my first question is, can you post your code and the presentation so that we can check it out?
Yeah.
Awesome. We'll link that to the video for the presentation, and then we'll also put it in the Python training training course so that you anybody can reference it from there if you want to use that. One of the practical examples in Python. Any other questions?
Can we play ping pong and see if it tracks the ball?
Yeah, actually it does.
Really?
Yeah.
Don't you need a faster camera?
No,
Fast speed
actually, with the last example, I was going to show you that because if you notice we can determine the FPS, the frame per second, and you know that if you are a gamer, you're not going to have more than 60 frames per second. And actually, with this algorithm, you are available to get. I have seen like 2,000 frames per second. Yeah, 2,000 frames per second. It changed between one and another, but it is a really good algorithm. So yeah, if you play ping pong, it's going to.
But I mean, recording with the laptop's camera, would it work?
Yeah, sure. I mean, you can with your phone, you can do live tracking of your face and everything, and it's the same.
No, I mean because of the speed of the ball when playing.
I don't think it'll be a problem.
Yeah, there are some, for example, remember that there were 7 algorithms. They are different.
Okay, I think I understand. So what Mark is saying, basically that camera cannot record at 60 frames. It's not like at 30 frames per second, and the ball is moving way faster. So at least it's gonna be a blurry the screen moving.
Yeah.
So that's what he's saying.
Yeah, probably. Yeah. In that case, yeah, it's right. Probably it's going to do it. In the example for my algorithm, it's not going to work because we are expecting a circle. But probably the other algorithms, they are more trained and more advanced. So.
Maybe if you use a higher resolution and higher frame rate camera, you're gonna have more
more data, but you also have to process more data. That means that you may have a data bottleneck over there. So I don't know what the expected or the good resolution and good proper resolution and proper frame rate is for detection, but there's probably data out there that says like, oh, you should be using 24 or 30 or 45 frames per second or 60 at half resolution or something like that, so that it detects properly. Because otherwise, you're just analyzing a bunch of pixels that are not, not a bunch of black or a bunch of white.
Too much blur.
Yeah.
Too much blur.
No, cool. Like it.
Awesome. CJ, any question? Guys, any question?
Okay, so I do have a question, but I do have to mention that looking at the title of the AllTalk, I thought we were going to talk about reference and objects in that, like in JavaScript, and it's actual objects, so it's nice.
This is way better than object tracking
Yeah.
in JavaScript.
Like reference.
Yeah.
Hey,
No, I
it's JavaScript.
use Python, but I just thought that's like that object, and it's not, it's like an actual object. It's nice.
Real life object.
Yeah.
Cool.
And that it was gonna be boring.
I'm glad it wasn't.
And it wasn't.
So now you know how to stack. But I would come, start tracking people.
Your stop Thank you, Rita.
Thank you very much.
Yeah.